Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with MetaGeek. Today's host is Casey Cathy, and he is their Customer Experience Specialist. He'll be presenting today, and if anyone has any questions, please feel free to submit them in the question box, and I'll read them off to Casey one at a time at the end of today's presentation. Thank you, Casey, so much for being here today and bringing us your presentation. I am finished for now, so please go ahead and take it on over.
Alrighty, thank you, Julie. I appreciate that. Hello, everyone. Thanks for joining. This webinar is going to showcase the core products that MetaGeek has to offer. These are all available at Microcom as well. Our agenda today. First, I'll be introducing myself and talking a bit about MetaGeek. And we're going to go over some Wi-Fi fundamentals, which are crucial to understand MetaGeek's products. So I'll just kind of briefly go over that. And then we're going to go over inSSIDer Office, Chanalyzer, and Eye P.A. We'll try and do a demo for all of those as well if we have time. And then I will finally open up the floor for some questions. So about me, my name is Casey. I'm the CX specialist here, which is just customer experience. I have a CWNA and a CWSP, currently working on my CWAP. And these are certifications put on by a company called CWNP, which stands for Certified Wireless Network Professionals. I highly recommend checking that organization out if you want to further your knowledge on Wi-Fi and get some certifications. And then you can also find me on Twitter at CathyFi. There's actually a huge community of Wi-Fi experts out there on Twitter that know a lot about Wi-Fi, and definitely I recommend hopping on Twitter and asking some questions. It's a very welcoming community as well, so definitely recommend that. About MetaGeek, we're located here in Boise, Idaho, downtown, and you can kind of see this image is a screenshots of our office. We're looking out at a window here. We have about 16 employees or so right now. We're a pretty small company here, and we just make Wi-Fi troubleshooting tools. We often make a joke that our Wi-Fi hardware is made from Idaho grown potatoes, as that seems to be what we're most known for here. So yeah, I'm just going to jump right in with some Wi-Fi basics. Kind of the most important thing to understand about Wi-Fi is that it's half-duplex. And what does that mean exactly? Basically, that just means, let's take a look at an Ethernet cable first. So an Ethernet cable is just a twisted pair of copper cables, kind of like this. And what this allows is for for traffic to travel in two different directions, left and right at the same time. But Wi-Fi, on the other hand, can only travel in one direction at a time. It's half duplex, so only one Wi-Fi device can talk on a channel at a time. And so it's much like a one-lane highway where traffic has to take turns going in one direction, basically. And I like to liken this a lot to a conversation with a friend where, if two people talk at the same time, they can't understand each other and cancel each other out. Well, Wi-Fi is the exact same way. Only one Wi-Fi device can talk on a channel at the same time. And so, and what that means is, let's say we have a client device here that wants to send some data to an access point. And so it sends over some data, and the access point says, check, I acknowledge that, and it sends some information back to the client device. It says, check, I understand. Meanwhile, while this conversation is happening, all of these other devices have to wait their turn to talk. They literally just wait and sit and stay idle, basically. So it's actually fascinating that Wi-Fi works at all when you think about this. I wanted to talk about some of the spectrum here. So the FCC allows Wi-Fi to operate on only two unlicensed frequency bands, the 2.4 gigahertz band and the 5 gigahertz band. And I just kind of want to talk about some of the advantages and disadvantages to both of these bands. So first of all, with the 2.4 gigahertz band, it has a much longer wavelength than the 5 gigahertz. In fact, the distance between one wave here is about 5 inches. And because of this, it has a greater range, so it can go a little bit farther, about 300 feet outdoors, so without any walls or anything like that. You know, almost everything works with the 2.4 gigahertz band, almost every client device. You know, we're talking about like RF chip readers, tablets, any laptop that you buy, it's going to work with the 2.4 gigahertz spectrum. As a result, the 2.4 gigahertz band is super congested with Wi-Fi devices and super congested with non-Wi-Fi devices as well. Baby monitors, wireless video cameras, microwaves, and we'll get into that a little bit later, talk more about that for sure. And because it's so small, there's actually only 3 non-overlapping channels, channels 1, 6, and 11. And you'll hear me talk about this a lot more, how important it is to really only select those 3 channels in the United States at least, because they're the only non-overlapping channels. Whereas in the 5 gigahertz, your wavelength is a lot shorter. In fact, the wavelength here is about, ironically, about 2.4 inches. So it's kind of funny, the wavelength on the 2.4 gigahertz band is 5 inches, whereas the wavelength on the 5 gigahertz band is 2.4 inches about. So because it's this smaller wavelength, it can't go as far, it can't pierce through walls as much, so it has a much lower indoor range. We're looking at about 90 feet. And also, not every device is compatible with the 5 gigahertz band. You know, cheaper laptops, they're not going to maybe have a 5 gigahertz chipset, kind of cheaper phones. But if you start kind of getting higher end equipment, they're almost always going to support the 5 gigahertz band, just because you can get a lot more data throughput through it. And take a look at how large the 5 gigahertz spectrum is. There's 24 non-overlapping channels, whereas there's only 3 in the 2.4. So clearly there's some good, a lot more space there. And I kind of wanted to talk about some of the standards, some of the standards in the 802.11 that the Wi-Fi Alliance has made. And so, you know, Wi-Fi was created in 1997 and with 802.11 Prime. And in 1999, they came out with the 802.11b and the 802.11a standards. And kind of the main things to take away here is the modulation schemes that were used. So at first they were using, I believe it direct sequence spread spectrum is what this stands for, but you don't have to know that. And what this means is this made kind of a curved shape on the spectrum. So you kind of see this curved shape if you see this modulation scheme. Whereas, yeah, 1999 and the introduction of 802.11a, they started using OFDM, which stands for orthogonal frequency division multiplex, which again, you don't have to remember that, not important. What you should remember is that this creates more of a straight haystack looking device on the spectrum. Part of my drawing, by the way, but so it's kind of a straighter looking signature on the spectrum, whereas this is a curved shape. And this is important when you're diagnosing some issues on the spectrum. And pretty soon here, we're looking at AX. I think AX is going to be coming out here soon. And of course, you know, if your chipset is AX compatible, of course, our software will show that for you. And since, you know, a lot of these Wi-Fi amendments, they're just raw radio frequencies, our WiSpy or MetaGeek's WiSpy will also show you all that stuff. So any amendments that are made on the 2.4 or 5 gigahertz spectrum, our tools will be able to see it. And so, yeah, again, with the 2.4, you know, each network is actually only 20 megahertz wide. So right here is only 20 megahertz separated by 5 megahertz for each channel. So this means that there's only 3 non-overlapping channels in the 2.4 gigahertz. That's 1, 6, and 11. So you'll oftentimes we'll only recommend those 3 channels if you need to figure out where to put your access point or router on. And of course, because there's only 5 megahertz of separation, if you have a network on channel 2 and a network on channel 1, there's going to be a lot of adjacent channel interference, and we'll get to more of that here in a bit. And so co-channel interference is a lot more preferred. The way I like to think about co-channel interference, or basically what I'm saying here is if you have 3 networks, this is like 3 networks we'll say on channel 1 here. This is a lot like eating dinner, with family relatives at like a family reunion or something. You're on the same table and you're able to have a conversation, but you politely kind of take turns and you kind of compete for time to talk. Now, the more clients you introduce, and clients are kind of like more people in the family. Let's say you have 20 people, just like 20 clients. Well, then your time to talk gets a little bit limited, right? So it's pretty important to just kind of pay attention to how many clients you have on a network, because each one kind of limits the time to talk. Whereas adjacent channel interference is a lot like eating at a restaurant with your family, where there's other tables going on and having conversations. And so what you end up finding is you just have to talk a lot louder in order to get past that background noise. So co-channel interference is much more preferred to adjacent channel interference, which causes a lot more issues on the network. And so this is kind of where spectrum analysis comes in. Spectrum analysis can see congestion, co-channel congestion. It can see adjacent channel congestion, but more importantly, it can see non-Wi-Fi devices, your baby monitors, your microwaves, your video camera phones. And that's something that Wi-Fi scanners will miss in your laptop. They're not going to see this device over here. So that's why it's really important to have a good spectrum analyzer, like MetaGeek's Wi-Fi and Chanalyzer or inSSIDer Office. And so, what our tools, Chanalyzer and inSSIDer Office use is they do use the Wi-Fi scanning in your chipset. So you can see what channels networks are using. You can see the signal strength here. That's what this y-axis is here. This is just showing the signal strength, so how close the network is, or how well you're able to see the network. And these are in dBm. But what spectrum analysis will also show you, it kind of combines it with the invisible RF. So it shows you the Wi-Fi congestion. So these are 2 very similar screenshots, but if you didn't have a spectrum analyzer, you would have no idea that there's this massive source of interference here. And this kind of looks like a cordless phone or something. So, you might have selected channel 11 over here to put your access point on, but without a spectrum analyzer, you wouldn't have known that there would have been almost no time to talk on this channel, because these Wi-Fi devices also demand time on the channel to talk. So I kind of wanted to talk about Wi-Fi coverage as well. This tends to be a commonly asked question, kind of what's a good signal strength to shoot for. And here at MetaGeek, we like to suggest -67 dBm. If you can walk around pretty much in any area that you're trying to get good Wi-Fi, and you can get -67 from an access point, you're going to be in good shape. You can pretty much do whatever you want at -67, Google Hangouts, streaming Netflix, YouTube, things like that. You're not going to drop any frames here. The lower you get here, that's when you start dropping more frames. At around -80, all you're really able to do is maybe check email or Facebook, very basic tasks. And then, of course, if you're seeing -30, that means you're probably right on top of the access point, and you're going to be flying in terms of speed. But again, main takeaway here is shoot for that -67. It's a great signal strength to shoot for. The MetaGeek software will kind of group in different groups. We have physical and logical mode. And what physical mode lets you kind of diagnose a physical AP, so one access point. And even if there's multiple SSIDs, it'll still consolidate it down to one access point on a physical AP. And so it's good if you just need to diagnose one access point, whereas our logical grouping will actually consolidate all the access points into just one SSID. So you can kind of diagnose just a SSID and kind of troubleshoot things like roaming from one access point to another and things like that. And I'll show you some more of these, how this works in our software here shortly. So yeah, I kind of wanted to go ahead and demo inSSIDer Office for you. So I'm going to go ahead and get that pulled up. All right. So now that inSSIDer Office is pulled up, and it looks like there's a little bit of delay from what you guys are seeing here, so I'll kind of wait until I can see that that is showing up on your guys' end. Okay, there we go. Looks like it went up. So with inSSIDer Office, when you first pull it up, right now we're in downtown Boise, so this environment is highly congested. As you can see, there's just so many networks. What's great about inSSIDer Office is this is a really great scouting tool. So right off the bat, you can see the 2.4 and you can see the 5 gigahertz spectrum at the same time, which is just a great little snapshot. And what I like to do is, first is, if I'm troubleshooting the MetaGeek network, I'm just going to go ahead and use this filter up at the top here, type in MetaGeek, hit enter, and then it just is kind of get rid of all that fluff. I don't really want to see right now all the other networks. I just want to focus on my network, which in this case is the MetaGeek network. And so right now I'm in logical mode, so it's grouping all my access points together, and you can actually just click on the SSID, and then you can start to troubleshoot the signal strength over time. And this is pretty neat. This is great for troubleshooting roaming issues. Right now I'm Ethernetted in and hardlined and talking to you guys, so I can't walk around with my laptop. But if I were to walk around right now, you would see the signal strength over time graph. If I were to walk away from this Planck AP that I'm connected to, this would start dipping, and then you would see the cafe, which is about 90 feet away from me, start to rise up, just because that beacon is now closer to me. So this is a pretty neat tool for kind of troubleshoot roaming issues and keeping an eye on that. And the greatest thing about this tool, in my opinion, too, is it gives you a good overlook at all the channels. So if you switch over to the channels view here, kind of in the top left, this is where it's pretty great to get a good idea for where to place an access point. So remember how, let's just focus on the 2.4 here. So I'm kind of going to draw a line here and just show, the difference, just from 1 through 11, just looking at the 2.4 gigahertz spectrum. So we want to take a look at channels 1, 6, and 11, because again, those are the only 3 non-overlapping channels. And inSSIDer Office gives you some pretty great information here. So first of all, it shows you this channel utilization. And so this is looking at the RF coming from a Wi-Fi. So I do have a Wi-Fi DVX plugged in right now. That's what this color information is down here, this green and blue and red and orange. And so right now I can see channel 1 is at about 9%, channel 6 looks like it's about 4% utilized, channel 11 is at about 9, almost 10% utilization. And then another thing that's really important to look at, because we want to look at 3 different things here: channel utilization, on-channel networks, and then overlapping networks. So looking at channel 1 here, I see that there's 19 on-channel networks. So that's 19 channels on channel 1. Channel 6 has 23 networks on channel 6, and there's 22 networks on channel 11. So far it's kind of an even draw for what I would select here. But remember, adjacent channel interference is even worse than co-channel. So we want to look over here, and we see there's 4 networks on channel 1. We see there's 11 networks on channel 6, and there's 27 overlapping networks for channel 11, whether that's channel 10, channel 9, channel 8. Somehow those networks are overlapping. So that's a lot of overlapping channels. So if this were me, I'd probably, looks like channel 1 seems to be the most clear channel. And of course, you never know when someone's going to be putting up a new network near you, or a new office building comes up. And so this is always constantly changing. So it's always good to have a tool like this to just keep an eye out on the spectrum, because you might need to end up moving your access point. So if I were to kind of want to know where to place an access point, and it looks like if you select a network, what's great about inSSIDer Office is it gives you a recommendation here. So I just selected an access point that I'm next to, and I want to know what's a good recommendation. Right now we're on channel 1, and sure enough, it's recommending channel 1, and that makes sense. I just showed you guys how many adjacent channels were on 6 and 11. I'm sure in the algorithm it saw that, and it's indeed recommending channel 1. And this will change sometimes, because like I said, spectrum and the networks around you will change. And it's pretty neat. You can actually go through all your access points and see what it recommends. So here's in the 5 gigahertz. Here's kind of something interesting. So right now we're on channel 157, and you can see our network highlighted right here on channel 157. It's actually recommending channel 52. So maybe I'll tell our IT guy to throw our network right here. And it's probably looking at the utilization. There's probably not many other networks over here. You know, and you can kind of see a bit of utilization here, whether or not that's MetaGeek traffic or another channel, not entirely sure, but it does recommend channel 52. So it takes the guesswork out of it, which is pretty great. That's a pretty neat aspect about inSSIDer Office. And so we do recommend inSSIDer Office for, you know, kind of scouting people and field technicians. And what's another pretty great thing that you can do is you can actually start a recording, and you can save that recording and then open it up in our Chanalyzer software, which I'm going to get to after this. So Chanalyzer is kind of that next step troubleshooting. It's the deep dive into spectrum analysis. So once you've kind of put away inSSIDer Office and made your recording, you can send that back to a field technician who's going to be a little more advanced maybe, and he can take a closer look at the issue with Chanalyzer. This is kind of the cable tester of Wi-Fi, is what we kind of call this. And we kind of like to market this as being able to see the invisible. So with a Chanalyzer, a pretty important thing that it can do is it can locate sources of interference. With the device finder tool, we'll see if I have a little GIF here. We have this antenna that you can actually plug into the Wi-Fi to directionally locate sources of interference, which is really nice if you're not sure where the interference is coming from. You know, things like I was mentioning, baby monitors, cordless phones, microwaves, things like that. And so kind of along the lines of Wi-Fi being half duplex and only one device talking at a time, well, when you introduce something like a microwave, these Wi-Fi devices are very polite. Client devices are very polite. It's in the 802.11 protocol. When they see something like a microwave or cordless phone operating in the same channel as it's operating on, they will wait until this device is over, right? So it's going to wait until your corn dog is finished cooking in the microwave before you can have any conversations on the access point, which is pretty, you know, surprisingly common. I see this all the time with customers, just non-Wi-Fi interference, basically, you know, completely wrecking their wireless network. Here's some examples of what the signatures look like for each of the you know, for just some examples of non-Wi-Fi interference. This is a baby monitor. These are super frustrating because, as you can see, they kind of they frequency hop. So you know, this one started out on channel 6, and then it hopped over to channel 9, and then it hopped over to channel 1. And this is pretty common for baby monitors, just to kind of frequency hop like that. And so that can kind of just cause intermittent issues. So you know, if you yeah, it's pretty common to see these wrecked home Wi-Fi systems. This is what Bluetooth looks like on the spectrum. Ironically, it does look like blue teeth, but that's not where the name came from. This is just what they look like. Fortunately, these are just more like claps. They don't really interrupt the Wi-Fi transmissions unless you have a lot of Bluetooth devices. Like this particular signature, we put like 100 or 200 devices and put them in Bluetooth mode. So this is an extreme example. You hardly see this, but a lot of times you will see Bluetooth just kind of clapping in and out. Shouldn't affect your Wi-Fi too much, fortunately. And then another good example is this analog video camera. You don't see a lot of these out in the wild anymore, but they still are out there, and they're really nasty. They really just wreck your Wi-Fi because they have these shoulders that just cover the entire channel. I mean, they're almost 20 megahertz wide in itself, so it would just completely disrupt your network if you had one of these operating. And again, you kind of need a Wi-Fi to really see if one of these things are present. Another great thing about Chanalyzer is you can pause or rewind your spectrum data. A lot like a DVR, you can, kind of isolate out and, kind of set your laptop down and let it record, go get a coffee or something like that and come back and see if you caught the intruder. And I'll kind of give you an example of that here pretty soon. And then the really great thing about Chanalyzer that Insider Office doesn't have is you can actually build reports, customized reports with the report builder accessory. This makes you look very professional, and I'll give you an example of how Chanalyzer builds reports, because we basically pre-filled a lot of information. A lot of Wi-Fi information comes in pre-filled out, so you don't have to type out, what everything means. Makes you look really professional. Then, of course, if you're deploying Cisco access points, we have a pretty neat accessory where you can actually remote in with the Cisco Clean Air accessory and just look at that spectrum remotely. And you don't even have to leave your desk. You can actually do this, an hour away or 2 hours away, wherever you just need the NSI key and the IP address of that Cisco AP. So I'm going to go ahead and open up Chanalyzer here and give you guys a demo recording, or just kind of show you guys how it works a little bit, and yeah, hopefully give you a decent feel for it. I'm going to go ahead and wait until that shows up here on the screen. Okay, perfect. So it looks like that's showing up for you guys. So the first thing you might notice is that Chanalyzer is a lot like Insider Office in the sense that it has the Wi-Fi scanning capabilities as well. So you see a bunch of networks down here, and you can still see all the networks broadcasting in these little haystack shapes. Very similar to Insider Office. So again, what I'm going to do here is I'm just going to go ahead and filter out, MetaGeek, just so I can only see the MetaGeek networks. And so, what's pretty neat is this is starting recording right now. If there was some sort of interferer right now, you can actually kind of select it, and you can go to the device finder and kind of start this tracking down screen here, which is pretty neat. But again, I don't have a device finder on me right now. Plus, I'd have to move around a bit, kind of knelt down with this webinar, so can't really demonstrate this. But essentially, the blue bar goes to the top. That means you're basically closer to it, or you're directing the antenna closer to the device. The lower it gets, the farther away. So it's basically playing hot or cold with a directional antenna. I'm going to exit out of there. One thing I really wanted to show you guys is this recording that we have of a interferer here. And I'll kind of show you a good use case for this tool. And I'll kind of wait for it to show up here on your guys' screen. Okay, so what's pretty neat about Chanalyzer is right off the bat, when I started this recording, if you take a look at the waterfall view over here on the left-hand side, you can kind of see that there's something going to occur. And what's nice is it's time-stamped. So this was taken at about 9:28 in the morning, and you can kind of see, 9:30, 9:31. You can kind of see at about 9:30, some sort of Wi-Fi device or non-Wi-Fi device started interfering on the network, and you can kind of see this red line here. So what's really, really neat about Chanalyzer, so you can actually just click and drag around that, and then you can essentially see exactly what it is, and you can just go to it right then and there. And so as you can see, there's something talking on this network that's super loud. And the neat thing about Chanalyzer is we help you identify what this might be. And so we have this neat little interferers tab that you can actually click on, and basically you can start dragging up these shapes here. So, I'm going to click on 802.11b and see if that's it. And you can just drag it up in the amplitude graph. And, I can tell, okay, that's clearly not Wi-Fi. If you drag it over here to this network on channel 11, you can kind of see what an 802.11b signature looks like. but I can tell that this interfering device is not 802.11. So, you know, maybe I'll go to this AV transmitter signature and drag it up here. And, you know, I can tell that that's not matching up quite right with the shoulders and everything like that. So then I'm going to actually go and, you know, I can tell it kind of looks like this Uniden phone. So you can actually drag the Uniden phone up, and yep, that looks like a match. And so you can kind of confirm that this is indeed a Uniden phone. And once you kind of troubleshooted the issue, one really neat thing is this report builder accessory. So I'm going to go ahead and open up and build a new report. Let's say this is for a client, and they wanted to see a good report. And so you can actually just, oh, let me go ahead and clear my drawings here. So you can actually just go and add, you know, that current snapshot right now in the density graph. If I just click add density graph, I'll actually see that interferer, and it'll throw it in there. It's going to explain the color scheme, which is really nice. So it explains that blue is less than 10% utilization, green is 20% utilization, yellow is 40% utilization, and red is over 50% utilization, which is a really good kind of key to keep in mind. And it throws those networks over there, so you can kind of type in some more details if you like. You can even add the networks table, which shows, you know, the current you know, situation. Looks like this network was an Apple router at, you know, negative 57 dBm on channel 149. And so pretty neat things that you can throw in here. Make yourself look very, very professional. You can even throw in the channels table, and just kind of prove that you know, found the issue, and you can take away the issue and kind of do a before and after, things like that. So yeah, it makes you look, you know, very, very professional. And that's kind of a pretty good use case for Chanalyzer. So I'm going to go ahead and exit out of Chanalyzer and move on to the next part of our presentation here. And I'm going to go ahead and wait for the view to show up for you guys. It looks like there's a little bit of a delay going on. Okay, so what I've kind of showed you is layer one troubleshooting with the spectrum analysis and Wi-Fi scanning of inside our office and Chanalyzer. So the next thing I kind of wanted to show you guys was the layer two, the packet layer. So if you can't solve the problem with spectrum analysis and Wi-Fi scanning with Chanalyzer and inside our office, I always recommend moving up to packet analysis and actually take a look at the conversations occurring on the channel. So, you know, with spectrum analysis, we see, you know, the sum of all the activity, we see all the, you know, congestion and things like that and non-Wi-Fi interference. But with packet analysis, we can actually see details about the 802.11 conversations unfolding on a channel. And that's pretty important. So I want to remind you, again, it's kind of getting repetitive, but Wi-Fi is half duplex. So only one device can talk at a time. So when this station sends over some data over to the client device, it says, check, I understood. And it sends over an acknowledgement. And the station says, check, okay, I'm glad you got that data I sent you. And again, only one device can do this at a time, which is really important to understand here when we're talking about packets. And again, this means that all the other devices on a channel have to wait their turn to talk. They just sit and wait while the conversation is finishing up with the client that currently has the conversation. All the other devices on the channel have to be quiet. And so kind of an important thing to think about too is data rates. So the closer a client device gets to an access point, it can achieve faster data rates, and it can get off and on the network a lot more quickly. So it's, you know, a lot of times I recommend disabling lower data rates, because if you have 1 megabit per second enabled on your AP, that means you can have client devices really far away and they can start demanding time to talk. Meanwhile, all these other devices that are so much closer, they have to wait their turn to talk. And the way I kind of like to liken this situation is this device over here on the fringe of the network is a lot like the slow kid at the back of a classroom. I'm sure you guys have all seen this kid, you know, kind of slowly raises his hands and asks a question to the teacher and grinds the lecture to a halt, and everyone has to kind of listen to the question, you know, And, you know, I'm sure you guys are all kind of aware and been in that situation, but that's a lot like Wi-Fi devices on the fringe of a network, just the slow kid in the back of the classroom, and everyone has to wait. You know, they could be having fast, quick conversations, whereas this client device over here just is slowing everyone down. It's trying to check an email or something, or maybe this guy's trying to stream YouTube. Meanwhile, all these guys that are just dropping frames like crazy because they have to wait for this client device over here to finish up its conversation at the fringe of a network. And so IPA will actually show these data frames with different colors, which is nice. Management frames are purple, control frames you'll see as orange, and the data frames you'll see as blue. We'll kind of go over what those frames or beacons mean. I'll use the words frames and beacons. They can be interchanged, or frames and packets rather. So management frames are, they help stations get on and off a network. So a really good example are beacons. And so when you open your phone and you look at the list of networks to connect to, basically every network is beaconing, saying, hey, I'm here, I support these data rates, I support this type of encryption, you can connect to me. And it does that every 100 milliseconds or so. It's actually crazy. But that's why you have a huge list of Wi-Fi networks that you can look at. They're just sending beacons out there, beaconing, like saying, hey, connect to me, I support these data rates. And probes, on the other hand, probes are kind of the opposite of beacons. Probes are, once you've disassociated from a network, your device will actually start probing for more networks or for networks that it's been connected to. So my iPhone, for instance, when I leave my house to come to work, it'll start saying, hey, Cases Network, are you there? And it'll say, hey, MetaGeek, are you there? Hey, Boise Airport, are you there? Because those are all networks that I've previously associated to. And that's why a lot of people actually suggest forgetting networks on your devices if you're having battery issues, because it literally goes through the entire list of networks that you've ever connected to, just asking probe requests. Hey, this network, are you there? Hey, this network, are you there? Hey, this network, are you there? And what's nice is when I do get to the MetaGeek office, it replies with a response, which we call a probe response. And it says, yes, I'm here, I'm MetaGeek's network, you can connect to me. And then at that point, it goes through an authentication process, and then it associates to the network. And so that's kind of what management frames are there for. Control frames, on the other hand, control frames basically control the RF media, make sure data and management frames get delivered properly. You know, I kind of was talking about this earlier, but ACK stands for acknowledgement. So you'll see a client send something over, and then it gets acknowledged, and it sends back acknowledgement frame basically. Just to ensure that it gets sent. Now, what happens if the device is too far away from the access point, and the access point sends some data and it doesn't receive an ACK or an acknowledgement? Well, then it's going to retransmit, and it's going to keep retransmitting that data until it receives an ACK or an acknowledgement. So IPA will actually show you retransmit rate, which can be a lot of reasons, right? If it's too far from the network, or maybe adjacent channel interference kind of causes a collision with the packets. So you actually do get to see retry rate in IPA, which is pretty nice. A block acknowledgement or a block ACK allows it to acknowledge multiple chunks of data at the same time. So instead of going data ACK, data ACK, data ACK, it goes data, 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 data ACK. So you can get more data through at one time, rather than having to go through all the management acknowledgements. And this was Blackhawk's ACKs were introduced with 802.11n, and that was a pretty great introduction there. RTS and CTS is request to send and clear to send. Basically, this allows two devices to not try and talk at the same time. It's similar to a conversation with, let's just say, two friends are trying to talk to you at the same time, but they can't see each other because maybe a wall is in between them. Basically, if one friend says, hey, I want to talk to you, I request to send some information to you, and you can say, yes, you can speak now, and you can talk to me. That alerts the other friend who can't see, the other person on the other side of the wall that you're in a conversation with the other friend first. And so RTS, CTS is just kind of a way to control the conversation. And then data frames are the most important frames that IPA shows. These are actually the only frames that go through the wire. The other two that we're talking about, management and control frames, are Wi-Fi only. They only occur on the wireless side of things, whereas these data frames actually go out, to the servers and everything like that. So these are the actual, these are your actual YouTube videos and video hangouts and things like that. And QoS is just quality of service. So this is just even more important stuff like voice. For instance, voice over IP is much more important, so it has priority over regular data to get out on the network. And then null data was just, really null data is not actually data. It's more for like power save pools and things like that. It's just, I think the people that created the standards didn't know where to throw it exactly. So it's also listed under the data category. I was gonna go over some airtime, how each Wi-Fi device kind of competes for airtime. And I'll kind of just fly through this. We could spend a whole hour on this process alone, but we're kind of running low on time. But basically, the thing I really want to kind of get out of this is that client devices, we'll say like station 4 and station 2, or just any device on a network, they essentially roll dice to decide who gets to talk first on a network. So in this example here, with time going this way, station 4 and station 2 both rolled the dice, and station 4 rolled a 9 for random back off slots, and station 2 here rolled a 7. And so they both counted 1, 2, 3, 4, 5, 6, 7. As soon as 7 hits, station 2 had an RTS and asked to speak on the network, and the station said, yep, you're good to send, and it started transmitting data. While this was occurring, all these other devices just waited their turn. They're just waiting, even though they kept their random backoff counter of 2 for station 4 here, and even station 5 and 6, and any other device or client on the network is just waiting for this conversation to finish. And then once it's done with its conversation, this finishes its remaining 2 slots because it originally rolled a 9. So now this one gets turned to talk, and this is just constantly happening thousands of times a second. Devices are just rolling the dice, deciding who gets to talk first, and then whoever wins that dice toss, will back off. So there's a lot more details to this, but that's it's actually pretty fascinating when I learned this, that that's what's happening on a network because Wi-Fi is half duplex. And so I think it's pretty important to kind of ask, how can we visualize these types of conversations? And Wireshark was a tool created a long time ago for Ethernet troubleshooting, kind of to see information flying back and forth on wired networks. And it was actually an open source software. There was, it's free right now. There's, just developers kind of work on it in their spare time. It's a great tool, but the problem with it is it's really difficult to visualize airtime usage. Since it was made for wired connections, it's kind of hard to understand what's going on in terms of Wi-Fi. So that's where Eye P.A comes in. And this is a MetaGeek software. Eye P.A stands for packet analysis. It gives you these multi-layered pie charts, which kind of looks like an eye. So that it's kind of 3 puns in one, because our engineers also really like beer. So that's why it's called Eye P.A. What's pretty neat about this is it looks at all the network, all the traffic on a channel, and it breaks it down really nicely into these layered pie charts. So the first layer we get to see here is the network. So this would be like the MetaGeek network, for instance. And then the next layer out, depending on the grouping you're using, this would be the access point, the actual AP that you can kind of troubleshoot and diagnose. And then you can actually take a look and see at the client next. So this maybe was an Apple device or something like that, right? Taking up almost a quarter of the airtime here. That's what this is seeing. Like, okay, this client device is taking up a quarter of the airtime about. And then of course, the very end, the very outer layer here of the pie chart, or the onion or whatever, is easiest to look at this. This is the actual frame type. So this particular frame type is a data frame. So this is actually a pretty healthy looking network. Looks like there's a lot of data throughput occurring here, with some minimal control frames over here in orange. Now I'll go ahead and I'll demo this here in a second. So again, yeah, control frames are orange, management frames are marked as purple, and the blue frames are marked as blue. So it's really great to visualize kind of what type of traffic is occurring on your network. Eye P.A currently supports a lot of common Wi-Fi adapters. We actually have been updating this software quite a bit, so I'm pretty excited to kind of show you some new things with it. If you just send a support a request or look at our knowledge base on support.metageek.com, you can find a list of adapters that are currently supported in IPA to grab these packet captures. The one that I recommend is the Linksys WUSB 6300. That's what I recommend. But that allows you to capture directly in IPA, and it is now AC compatible, which in the past, I think the last time these webinars were done, it didn't support AC directly in IPA, but now it does with these supported Wi-Fi adapters. So our engineers have been very hard at work making that happen. You can also import PCAPs from Mac OS. These are pretty great adapters. MacBook Air, MacBook Pro have 3x3 spatial streams and a 2x2 spatial stream with the MacBook Air. Of course, you get AC information. These are regarded as some of the best wireless adapters that you can get your hands on easily. So if you have one of these devices, there's a couple pretty great ways to get some PCAPs and sniff the air for some PCAPs, which can then be imported into IPA. And then, of course, some enterprise grade APs will also produce PCAPs for you. There's some workarounds with Linux and regular adapters, but these don't always work with IPA. We're trying to constantly update it and everything, but not everything works with it. So I'll go ahead and open up IPA here and kind of just show you guys a quick demonstration of some cool things that you can do with it. And after that, I'll go ahead and turn the floor to Julie for some questions. We'll not open that. So first of all, we'll see if you guys will be able to see the new way of capturing. So I have two different devices plugged into my machine right now. I'm going to click capture, and what's pretty neat is IPA will actually let's see if you guys can see this here. Yeah, so it'll give you this little security message saying, would you like to install these drivers? So I do have a Linksys plugged in right now, and you can actually install the Tamasoft drivers over your adapter. I'm going to say don't install because I actually do have an Air PCAP right now, which is just already natively built in. So yeah, it recognizes that I also have an Air PCAP, so no need to install drivers over my other network adapter here. So I'm just going to do a quick start on channel 1. This is just monitoring current channel 1 in my environment. So I'm not doing any throughput tests or anything. I'll show you recordings of some pretty neat things, but this is just a quick way to kind of show you how it actually captures natively within IPA. And so I think we have, MetaGeek test network here and a bunch of other SSIDs. Channel 1 is obviously super congested. Interestingly, if you look out on the outside here, you see a lot of management frames. There's not a whole lot of data being passed back and forth here on this channel. Looks like it's mostly management frames. Another thing you can kind of take a look at is over here on the left-hand side. You can kind of take a look at the data rates occurring. So if you notice on channel 1, a lot of fringe networks, I'm seeing a lot of 1 megabit per second, about 50% of this PCAP involves a 1 megabit per second data rate, which means that these networks that I'm seeing, Wi-Fi, which is the building that we're in, they're allowing legacy data rates. So if I were to drag up an iPhone up here and connect to the Wi-Fi, I would be slowing down everyone's Wi-Fi, and this is about 4 stories below me right now. So it's really neat to be able to see an IPA data rates because you can really kind of get an idea for what might be slowing down the network, and knowing that maybe you should try disabling these lower data rates. One thing I wanted to kind of show you guys, if you go to the start here, we actually have, this is available in the trial too. So if you just Google IPA trial, you can get access to these recordings here. This lots of virtual SSIDs is what it's labeled. I'm going to open up this one. And this is a PCAP that was sent to me by a customer very recently. And this, I see this all the time, so I thought this was a great illustration of what happens when you have too many virtual SSIDs on a channel. And so I think this was on channel 1, if I'm not mistaken, or this might have been in the 5 gigahertz, I can't remember. But right off the bat, you can kind of see it's actually really quite pretty. I mean, IPA really does have some really beautiful imagery here. But right off the bat, you can see the data, the frames around the outside rim here are all purple, and they're all just perfectly symmetrical. And this is a classic example of what management overhead looks like. So remember how I told you how beacons, which are management frames, purple frames, they say, hey, on this network, I support these data rates, I support this encryption type, connect to me. Well, this particular customer actually has 35 SSIDs set up on this channel. And so all that's happening on this channel right now is just management overhead. Those beacons actually do take up time, especially when you start introducing more and more virtual SSIDs. And that's why we stress at MetaGeek to just please keep it to 2 or 3 virtual SSIDs, no more than that. Otherwise, you're eating up all your airtime here with management overhead. And the ironic thing here is, I'll get my annotation tool. The ironic thing here is there's only 10 clients connecting to anything on this channel, but there's 35 SSIDs. And so it's pretty great to just open up a PCAP and IPA and see this immediately, and it kind of immediately know what's going on. So another pretty great thing here that you can do with IPA is, let me get out of my annotation here, is you can go to the packets tab over here, and then you can kind of start troubleshooting packets back and forth. So if you are familiar with Wireshark, then you can actually filter this down. And what's neat is you can actually drag the sliders here on the airtime, and like here's a spike, for instance, where I think a lot of data was being passed on this channel. So you can actually kind of narrow down the spike. And once you've narrowed that down, you know, and you can filter even more. We still have the same filtering here, so you can, you know, filter your network, you can filter data rates up here at the top. And then once you're done kind of isolating your selection, and if you want to drill down even further, you can actually go to File and Send to Wireshark. And this will essentially send all that information that you just filtered down to Wireshark, so that you can then begin troubleshooting even further. Because of course, once you're in Wireshark, you can really start diving deep into radio tap headers, and you know, if you kind of know what you're doing, you can really start isolating. So even if you are an expert, you can still use IPA to just quickly filter down, isolate the issue, and then troubleshoot it in Wireshark at that point. I'm going to go ahead and exit out here. Lastly, I'm going to go ahead and show you, I'll just show you MetaGeek Office here. This is one I took, and this is available on the trial version of IPA as well. So I just took this PCAP of the MetaGeek network just right outside my office here. What I was doing is I was streaming some Netflix to an Apple TV, so from my iPhone. And so if you start at the first ring out, you see the network that you're on. You go one more layer over. This is the access point. It's labeled the Plank here. That's right next to me. And if you go one more layer over, you can actually see that Apple device. So this was my iPhone at the time, and you can just see all that data, which was taking up, you know, this is almost 3/4 of the airtime. So this was a very intensive throughput test, basically, and all it was Netflix, you know. So it kind of just shows you what Netflix looks like in terms of airtime, and how any other devices on this channel would struggle to find time to talk. And fortunately, you can kind of go look again, you know, looks like I had a pretty good data rate over here at 72 megabits per second, 24 megabits per second, 74% of the time. So pretty solid. We're not looking at 6 or 1 megabit per second. So we're using good data rate, which is nice. But what's really great is if you go to this Analyze tab over here and you check the network. I'm pretty excited to show this to you. Actually, our engineers are working on insights, kind of finding issues that that they see with the PCAP automatically, and giving you a little bit of insights. So right now you can see that this has a high retransmit rate, 4.13%. And it kind of just gives you this little notification that this Apple device, and it even gives you the MAC address, which is pretty neat if you have the MAC address, had these retries basically. So it sent a transmission and never received an acknowledgement from an access point. And so it kept retrying and retrying and retrying. And so what's pretty neat is it will give you some suggested solutions. So saying maybe it's a Wi-Fi chipset issue. Maybe there's some adjacent channel interference going on. Maybe there's some non-Wi-Fi interference going on. So maybe it's good to get in there with a spectrum analyzer like WiSpy DBX. So Pretty neat, and this is constantly being updated. That's what's really cool is we're really focusing right now on increasing these insights, getting them even smarter, more dialed in, and of course, we're always looking for feedback for solutions. If you guys come across your own insights or things that we're not catching, we'd love to hear and see what you guys recommend. So yeah, with that, I'll go ahead and open up the floor for some more questions and send this over to Julie.
Thank you very much, Casey, for that presentation. We enjoyed it very much, and I do have some questions. Let's go ahead and get started here with the first one. Is MetaGeek able to analyze any and all manufacturers' devices?
Any and all manufacturers' devices. Well, you know, if it's making noise on a network, we're going to be able to see it. And, you know, keep in mind that, you know, when you say devices, are we talking Wi-Fi devices? Are we talking non-Wi-Fi devices? You know, if it's a Wi-Fi device, then we'll be able to at least see it in IPA as a client device because it's associated with a network or it's sending probe responses or probe requests. Non-Wi-Fi devices, you would need a spectrum analyzer to see. You wouldn't see it with the chipset in your adapter and with our software if it's a non-Wi-Fi device.
Thank you very much. Next question here for you. Will the analyzer tell us that something in the 11 or 7 gigahertz is in the area? Perhaps it won't report it, but will it show that frequency to any degree?
And did you say 11 gigahertz or 7 gigahertz? Is that what you said,
yes.
Julie?
Yeah.
Yeah, so right now our software or our spectrum analyzer can only analyze Wi-Fi frequencies, which is the 2.4 gigahertz and the 5 gigahertz. We used to sell a 900 megahertz, which is a little lower, but no, we don't have anything going above 5 gigahertz right now. I think it taps out at about like 5.4 gigahertz. Anything 7 gigahertz, 11 gigahertz, we don't really offer any tools to see that, nor do we have any sort of alert if something like that happens, because we just can't see it. We're more interested in Wi-Fi spectrum right now.
Thank you very much. Next question here. With inSSIDer Office, when filtering, is it by character or is it case sensitive when searching networks?
Oh, that's a great question. inSSIDer Office isn't case sensitive. I tested that out personally actually last night because I noticed that IPA is case sensitive. So if you're filtering an IPA, that one does appear to be case sensitive, but and I think that's just a bug mainly that we need to work out since we are introducing a lot of updates right now to IPA. But no, inSSIDer Office, you should be able to you shouldn't have to worry about case sensitivity unless you have some networks that do have you know, case sensitive differentiation. Then you might want to make sure you're capitalizing the right characters.
Thank you for that. Next question. Again, with inSSIDer Office, is there a way to integrate the router or access point, or is it just a separate application?
Yeah, great question. Right now, it's a separate application. It's quite an engineering difficulty to actually pull in the config of a router, especially because every router is different and proprietary. We're trying to bridge that gap a little bit with inSSIDer, with some insights and some packet analysis. So if we see that you're using, let's say, an Arrowhive router, we might give you some more detailed insights on exactly what you need to do in that config because we know exactly what that config looks like. But no, there's really no way to make those changes automatically for you. You would still have to go into the router config, make those changes just based on the insights and the recommendations from inSSIDer.
Thank you, Casey. Next question here. How does the software compute the recommendation? Is it by the number of users connected to that channel or network?
Great question. So inSSIDer Office uses it's a pretty advanced algorithm that I'm pretty confident in actually once I kind of learned. And again, this is some, you know, engineering stuff here too. So even I don't have my mind completely, I haven't memorized the exact algorithm, but essentially what it takes is it takes the utilization from the WiSpy, which is spectrum analysis, which is essentially how many users are on the network. So if you did have 100 to 200 clients on a network, it would have a high utilization on that channel, and it would put that as a percentage. And it does take that into consideration when recommending channels. And then it also takes in two other numbers: co-channel networks and adjacent channel networks, kind of like what I was showing in inSSIDer Office. And so it accumulates all three of those things. It weighs the adjacent channel and the utilization a little bit more. So there's a little bit more weight in the algorithm, so that the co-channel interference, that one's less weighted. It's not going to affect the score as much. And it kind of goes, and you know, I don't know the exact formula, but it uses all three of those things, and then calculates the best channel for you based on what also is clear. It also looks at what's clear, so it makes sure that the channel it's recommending is clear of spectrum as well. So yeah, it does take a look at how many clients are connected, in the sense that you can see that with the spectrum analyzer. So you do need a spectrum analyzer to get the best recommendation from inSSIDer Office.
Thank you, Casey. Next question. Does a microwave signal run no matter if it is being used or not? And will it amplify the interference if it is on and running?
Yeah, so really microwaves only, they have to be running to actually emit that interference. So if it's just plugged in and not currently running, you're fine. Shouldn't have any interference. But yeah, that's why we find at lunchtime, that's when a lot of Wi-Fi issues occur, because people are microwaving their food. It's that actual microwaving that is causing interference. And sometimes if you have usually it's leaky microwaves too. Kind of starting working here, I didn't realize how often microwaves leak small amounts of RF, which is just enough to throw off a Wi-Fi network, because Wi-Fi networks are already kind of fragile in terms of they're limited to 1 milliwatt output power. So even just a little bit of leakage from a 2.4 gigahertz microwave is going to throw off your network. And so you see a lot of issues at lunchtime, but it does have to be running to actually interfere.
Thank you for that, Casey. Next question. In regards to baby monitors, is there a best location to place them to have the least amount of interference?
Yeah, good question. Basically, as far away as possible from your router, which obviously, you can only do what you can do if you have a baby monitor set up. But yeah, the farthest away as possible from your router is always good. And then if you can set up the 5 gigahertz network on that router, that's an even better solution, so that it's okay if it's kind of frequency hopping down there in the 2.4, because your devices are going to be connected in the 5 gigahertz anyways.
Thank you for that. Question, next one here. Does MetaGeek have any plans on bringing back the WiSpy 900X?
That's a great question. We're constantly looking at the market, and if that market does come back, particularly the 900 megahertz market, that is something we'll consider, because we still have the plans and everything for it. And we just gotta wait until that threshold of demand kind of reaches a certain point before we'll reintroduce it. Right now, we don't have any immediate plans to reintroduce it, but it does look like there's a couple Wi-Fi amendments coming out that might utilize that 900 megahertz. And again, our focus is Wi-Fi, so if that does happen, I think that's going to be something that we consider much more seriously if Wi-Fi standardizes that frequency band.
Thank you, Casey. Last question here. If you upgrade the software itself, are the devices future-proof that the existing customers are entitled for the new feature, just in case you are releasing them, or do they have to buy a new subscription for the device?
Yeah, that's a great question. So kind of you have to think about that in two different frames here. So first of all, the actual hardware of your device has to be able to support the new standard. And we'll just use 802.11ax, which is just on the horizon here. You would need to get a laptop, for instance, that can see AX in order for our software to show it, because we're just using the internals in your laptop essentially. So at that point, our software will show it. And then kind of from a software perspective, in terms of updating and actually having, the 802.11ax information and insights and things like that, once you do have upgraded hardware, yeah, you probably would need to stay current on our updates program. So if you're using Chanalyzer or Eye P.A, those are on our Medicare program, which you can also get Medicare extensions for Microcom as well. and keep up to date, just so you can keep getting those updates if you aren't up to date already. Right now, Insider Office is good indefinitely, so that one's not on our Medicare program. So you'll be good with Insider Office, but yeah, Chanalyzer IPA, you would need to make sure you're up to date in order to keep grabbing those insights on new amendments and kind of future proofing in a sense.
Casey, thank you so much for answering all of those questions, and thank you to everyone for attending today. And if anyone has any further questions, please feel free to contact our sales rep or email us at sales@microcomtech.com. If you wish to view the products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has, and we will upload it to our Microcom YouTube channel so you can view it again. Thank you, Casey, for your time and all of your information today. We greatly appreciate it. Have a fantastic day.
Thanks, Julie.
You're welcome.